Hello and welcome to this video. Originally, my intention for this video was to revisit the Fleet server as a follow-up to the video on running standalone Elastic agents. But the Fleet server video ended up being very long, so I decided to break it up into two parts. In this first video, I will set up Elastic and Kibana with self-signed certificates. This will include setting up a certificate authority to sign certificates for the domains elastic.evermite.net, kibana.evermite.net, and fleet.evermite.net. If you don't plan on using Fleet servers, you can just ignore any mention of Fleet servers in this video. The second video will be on running Elastic agents with Fleet servers. If you don't care about Fleet servers, then you can just ignore the second video. So let's talk about installing Elasticsearch and Kibana. If you have been watching videos on my channel, you will know that I have videos for setting up the Elastic Stack and for setting up the Elastic Cluster. And in those videos, I used a combination of public certificates and some certificates that Elasticsearch automatically generated. I decided to revisit the installation of Elasticsearch by using only self-signed certificates. This means I will also generate my own certificate authorities. Much of the Elastic documentation uses this approach, but some people I know had trouble getting things to work, so I hope this video will help them out. If anyone has any questions after watching this video, you can leave a comment below or email us through our website. So let's get started. I have 3 different Linux servers, each with Ubuntu 20.04 installed on them. I've also got domain names mapped to each of these servers. So I've got kibana.evermite.net mapped to a server that we will use as our Kibana server, fleet.evermite.net for the Fleet server, and elastic.evermite.net for the Elastic server. Now, because these are brand new installations of Ubuntu, I'm going to update the distribution and install some of the packages that we would normally need. So I'll type apt-get update apt distribution upgrade, automatically say yes to everything. And some of the tools that we will need, I like working with the Vim text editor. We'll need curl, newpg, and gpg. So we're going to run this command on each of the servers. And I'll wait until everything is done. Okay, it looks like all the distribution updates are done. So now let's actually install Elasticsearch on the Elastic server, which is pretty straightforward based on these instructions here, which is get a public signing key, install a dependency, update the repository definition, and then just do the apt-get update and install Elasticsearch. So I'll just copy and paste each of these commands into the Elastic terminal and let things go. And just like that, Elasticsearch has been installed. Elasticsearch comes with a default super user account. The username for that super user account is Elastic. And in this installation, there's an initial password that has been assigned to this super user account, which is this one right over here. I'm not going to write down this password because I plan to reset this password very shortly. So let's actually configure Elasticsearch and get it up and running. All the configuration files we need are going to be found in this directory, and specifically this elasticsearch.yaml file. So let's go ahead and edit this. The first thing we'll do is set the name of this instance. I'll just call it ESDemo. I'm not going to set the node.name or else it's going to end up setting up a cluster with more than one node. But for this demonstration, I only want one node in this cluster. So I'm just going to leave this line commented out. All right, so for this, we need to set our network host. I'll just put in the usual elastic.evermite.net, which is the server. And I'm going to use the default port of 9200. I'm not going to set the seed host or initial master nodes because I only want a one node cluster. I don't want more than one node. And this, we're going to have to configure the SSL settings over here. This section here is the transport SSL. These are the SSL settings used for connecting other Elastic nodes to this cluster on port 9300. I recommend you keep these settings as they are if you plan to create a cluster of multiple nodes later on. If you need more information, you can watch my video on setting up an Elasticsearch cluster. But right now, these settings will reference SSL certificates that Elasticsearch automatically created when we ran the initial apt-get install command. If you don't plan to add any more nodes to this cluster, you can completely ignore this block of configuration and just leave it alone. This section here is the SSL settings for the REST API on port 9200, which most things will connect to. Kibana will connect to this, the Fleet server will connect to this, the Beats library will connect to this, your curl calls to the REST API will connect to this, and pretty much everything else will connect to this. Right now, this YAML file is expecting to use the self-signed certificate that Elasticsearch automatically generated when we ran the apt-get install command earlier. Actually, let me show you where these auto-generated certificates are. These are the certificates that Elastic automatically created at the time of installation. The http.p12 is the private key store for the certificate authority, and the http_ca.cert is the public key for the certificate authority. And if we save what we have in our Elasticsearch YAML file without making any more changes, then Elasticsearch will use these certificates. And that could be fine. But later on, I want an SSL certificate for the domain kibana.evermite.net. And I also want an SSL certificate for the domain fleet.evermite.net. I also want a certificate authority to sign the certificates for kibana.evermite.net and fleet.evermite.net. For me, it would be convenient if I could use the http.p12 and http://ca.cert to sign my certificates for kibana.evermite.net and fleet.evermite.net. And I did try to use some Elasticsearch tools to do this, but I kept getting a prompt for a password that was protecting the http://p12 and http://ca.cert files, and I couldn't figure out what that password was. So to make a long story short, I'm just going to create new certificate authority files without a password. Then I'll use the new certificate authority to create and sign certificates for elastic.evermite.net, kibana.evermite.net, and fleet.evermite.net. So basically, I keep things simple by using one certificate authority to sign them all. So let's go ahead and make that certificate authority. I'm going to go to the USR share Elasticsearch binary directory. In here are a lot of the command line tools that come with Elasticsearch, so you can use these to do quite a few things. The one that we want to use is the Elasticsearch-cert util command. And this command will generate the certificate authority files that we need. So let's continue. I'll pass in the CA option for certificate authority. Private key must be in PEM format. And let's save things to the certs directory with ca.zip file name. All right, let's take a look. Okay, so I see it here. It's the ca.zip file, and let's go ahead and unzip it. All right, I need to install the zip program. So one moment. And now we'll try to unzip the ca.zip. And now we can see the private key for the certificate authority and the public key for the certificate authority. So at this point, we can now actually make a certificate for our elastic.evermite.net domain and have it signed by these new certificate authority files. So let's return to the binary directory because I am going to need the Elasticsearch-cert util command again, but this time I'm going to pass in the option cert because we're making certificates. I'm going to save the file to the etc Elasticsearch certs directory again, but with the file name elastic.zip. And I'm going to name this certificate, I'll just call it Elastic, but we can call it anything you want. And we're going to sign it with our new certificate authority. So for the public key, I'm going to reference the etc Elasticsearch certs ca/ca.cert file. So we just made this. And for the private key, we're going to reference the certs ca.key file. And I'm going to make this certificate against the fully qualified domain name of elastic.evermind.net. And if I weren't using a domain name, and if I were using an IP address, I would actually just type it here like this. But because we're using the fully qualified domain name instead, I don't really need this IP option. So finally, I'm just going to save the private key in PEM format. All right, looks like everything is made. Now let's take a look at the etc Elasticsearch certs directory. And I can see my elastic.zip here. So let's unzip it. And just like that, we now have our certificates for elastic.evermind.net. So now let's go back to our Elasticsearch YAML file and let's fill out the paths to our certificates and certificate authority. So certificate will be, I'll type in the relative path, certs elastic.crt for the public key. And for the private key, I just changed this to .key. And because this is a self-signed certificate, let's put in the signing authority here. It'll be the certs/ca/ca.crt file that we made. And we don't need the key store file. And I think that should be it. So let's go ahead and change the ownership of all these files to make sure they're owned by the Elasticsearch user, just so that when Elasticsearch starts up, everything works. All right, so I'll enable Elasticsearch, and now let's actually start it. Okay, let's check the systemctl status. Okay, no errors, so that's good. And if you want to look at the error logs, you're going to need to know the cluster name. So I'll copy this. And the error logs can be found in the var log elasticsearch cluster name.log. And if we just look around, we can see that there's really no mention of errors here. So we should be good. To check that Elasticsearch is up and running, we can ping one of the API endpoints. But to ping the API endpoint, we need to know the super user's username and password. And I didn't write down the password. So let's go reset the password for the Elasticsearch super user. So I'm going to go to the USR share Elasticsearch binary directory, and here's the command that we can run: Elasticsearch reset password -i for interactive, and we're going to reset it for the user Elastic. Oh, let's see what's going on here. Oh, okay, I see. Right, our self-signed certificate is for the domain elastic.evermind.net, and when I ran the reset password command, it used a different domain. It used localhost. So I'm going to explicitly state --URL https elastic.evermind.net 9200, and hopefully this will work. Great, so I'll say yes, and I'll just keep the password simple, abcd1234. And that should be good. Let's try using curl to hit our API endpoint. So curl get elastic abcd1234 https elastic.evermind.net 9200. Okay, curl failed to connect to our server because it doesn't recognize the certificate authority that we signed our certificates with. If it were a publicly signed certificate from Let's Encrypt, Sec2Go, and hundreds of others, the root certificate public key of those authorities typically comes bundled with clients like curl. In fact, it comes bundled with other clients too, like Chrome, Firefox, Postman, and most developer SDKs. But because we made our own certificate authority, a client like curl won't have our certificate authority's root public key unless we explicitly specify it. And this is why clients like curl, Chrome, Firefox, and such will give a warning saying it doesn't trust the certificates that will be used to encrypt upcoming traffic. So let's run our curl statement again, but this time tell curl our CA's public key so that it can verify the entire SSL chain. So I'll just add the flag --CA cert etc Elasticsearch cert ca.cert. All right, looks like everything is up and running. I can see my cluster name right here, ESDemo. So at this point, let's install Kibana, which is basically the same as installing Elasticsearch, where we download the public signing key, install a dependency, update the repository definition, and then finally just install Kibana. So let's copy and paste each of these commands into our Kibana terminal. All right, Kibana should be installed now, and we can start configuring Kibana inside this etc Kibana directory because all the configuration files, because the configuration file we need to work with is right here. So let's go ahead and configure our Kibana instance. I'm going to say the server port is the default 5601. For the server host, we should use a non-loop back address. So I'll just do 0.0.0.0, and that will give us public access through a web browser as well. For the URL, I'll just paste in the full URL to our Kibana instance, including the port number, and we are going to use SSL. So for this section here, we're going to create our own self-signed certificate for the kibana.evermite.net domain, and we're going to need to do this from the Elastic server. So let me find the terminal window for Elastic. Here it is. So now let's make a directory to host or to house our Kibana certificates. And then we're going to run the Elasticsearch cert util command again, just like we did for elastic.evermite.net. But this time we're just going to pass an option specific to Kibana. So I'm going to save the Kibana certificates over here. And I'll just name this certificate Kibana. And then we're going to need to sign it with our certificate authority that we made earlier. And I'll specify the public key like this, just like we did for Elastic. And then the private key like this. All right, just like we did for the elastic.evermite.net. And this certificate is going to be for the domain name kibana.evermite.net. Now, if we were using IP address instead of domain name, I'd type it in like this, but we're just using domain name, so don't need that. And we're going to save the private key as PEM format. And that should be good. So I'm going to go to this directory, unzip, and those are our certificates for kibana.evermite.net. So let's copy over the certificates from Elastic over to Kibana. I'm going to make this directory on Kibana first. This one will be for our Kibana certificates. And this one will be for the certificate authority. Okay, so let's copy over the Kibana certificates first. Okay, so now let's copy over the certificate authority onto Kibana because, as I mentioned earlier, clients connecting to Elasticsearch need the certificate authority to verify the whole SSL chain because they're not the publicly signed certs. Okay, certificate authority is there. And our kibana.evermite.net certificates are here as well. So now let's go back to our kibana.yaml file. And let's actually enable SSL for our kibana.evermite.net URL. So enabled. For the actual certificate, we're going to need to type the full absolute path. It can't be a relative path. All right, and for the key, it would be this one here. And we're also going to need to specify the certificate authority for Elasticsearch because that was the signing authority. So I'm going to type it here. And that should be the configuration details for our SSL certificate. Next, let's specify the URL for our Elasticsearch server, which is https elastic.evermite.net. And we're going to need to specify the certificate authority as well, but I'll return to that later. Kibana needs to connect to Elasticsearch with credentials, and we could use the username and password, but that's not the most secure. So I'm going to use the service account token instead, which is basically like an API token. But to make this service account token, I need to use some command line tools from my Elasticsearch server. So let me open up this window again. And then on the Elastic server, go to the USR share Elasticsearch binary directory. And in here, the command we need is the Elasticsearch service tokens. And we'll pass in the options create elastic/Kibana. And we're going to name our service token Kibana_token. And now I'll just press enter. And there's our service token right here. And just to make sure I don't forget this token, I'm going to save it to this text file right here. So let's return to the etc Elasticsearch directory. And in here, you're going to notice a new file called the service_tokens. And in this file is actually our new service account token for Kibana. So let me open it up. And there you can see the Kibana_token with the encrypted version of the token on the right. So now let's make sure that Elasticsearch can actually read this file by changing the ownership. All right, and now let's restart Elasticsearch. Okay, let's check the status. Okay, great. There's no errors so far. So let's ping the API just to make sure everything is okay. So I will curl get elastic abcd1234 elastic evermite net 9200, and I have to remember to pass in the public key of the certificate authority. And yeah, looks like everything is up and running. Let's go ahead and grab our token, which I think I placed over here. Okay, so that's our token. And coming back to our kibana.yaml file, I could just go ahead and copy this token and basically just paste it in here and start up my Kibana. But I don't like leaving sensitive information in a file like this, so I'm going to use the Kibana key store instead to set this Elasticsearch.serviceAccount token property. So I'm going to exit out of here and let's go to the USR share Kibana directory into the binary directory. And in here are some of the command line tools that come with Kibana. And we are going to use the kibana.keystore command. And we're going to add the property that we saw in our kibana.yaml file, which is the elasticsearch.service account token. And I'll type hyphen, actually just like that. So I'm going to be asked for the value, in which case I just copy this, paste it in here. And now if I start up Kibana, this property will be loaded into the initialization during runtime. And if I go over here into the Kibana directory, you can see that there is this kibana.keystore file. And the service token has been encrypted into this file over here. So let's go back to our kibana.yaml file and continue editing the things that we need to edit. So this property has been taken care of now. And what else do we need to do? All right, the final thing we need to do is that I specified that we will be using an SSL certificate. It's a self-signed one. So we're going to have to pass in the certificate authority to be able to connect successfully to Elasticsearch. So let's go over down here, certificate authorities, and we're going to type in the full path to it. Sorry, it's Kibana certs elastic.evermite.net ca certificate authority cert. And we will enable full verification of the SSL. And I believe at this point, we've done everything we need to do with this Kibana YAML file. Let's actually make sure that all the files that we've created here are going to be owned and accessible by the Kibana user. All right, let's start things up. Let's take a look to see if Kibana is up and running. No error so far. Yeah, no real errors in here. So I think things should work if I load up the URL in incognito window. I'm going to press enter. All right, because it's a self-signed certificate, we're going to get this warning. I'll use my super user. All right, Kibana is up and running, and so is the entire Elasticsearch instance. And that's it for this video. In our next video, I will continue with setting up the Fleet server. If you found this video helpful, then give it a like, and you can subscribe to this channel to be informed of videos as we release them. See you in the next video.